Hi students, today we're going to talk about chemical bonds and oxidation numbers. Chemical bonds. There are two main types of chemical bonds we're going to talk about. The first we're going to talk about is ionic bonds. Ionic bonds are bonds where electrons are transferred. They're usually between a metal and a nonmetal. That is very important that you know that it's between a metal and a nonmetal. They're usually solids at room temperature and they have high melting points. The smallest particle is an ion, which is any atom that has gained or lost electrons. An example would be NaCl. Here would be a picture of NaCl where you see that the one electron from sodium is being transferred to chlorine so that they both end up having 8 electrons around so that they become stable. Here's another picture of the exact same thing without it moving. So the one valence electron from sodium goes to chlorine. Chlorine now has 8 around it. Sodium has 8 in its inner shell to become stable. And then the sodium becomes positive. The chlorine becomes negative because opposites attract. They bond together. The reason why sodium becomes positive is because it lost an electron. And remember, electrons are negative. So it now has more protons than electrons. Chlorine becomes negative because it gained an electron, so now it has more electrons than protons. The other type of bond is a covalent bond, which occurs when electrons are shared. This occurs between nonmetals, so only nonmetals. That is important as well. It's usually liquids or gases at room temperature, and they have a low melting point. The smallest particle is a molecule. An example would be H2O. Remember, hydrogen is a nonmetal. Here would be an example where they share electrons. So oxygen has 6 valence electrons, and then it's going to share one with one hydrogen and one with another hydrogen. And so that makes hydrogen end up having 2 electrons around it for each, and hydrogen is stable with that, and oxygen has 8 electrons to make it stable. We're going to have 2 examples, LiBr and C2H2. You should try to determine if these are ionic or covalent. Use your periodic table. So the first one, LiBr, I have a periodic table here. Li is here, and Br is here. Well, if you have anything on the left-hand side of this stair-step line, so it's on the left-hand side of the stair-step line, then it's going to be ionic. So this one is ionic because Li is a metal. Now, the next one was carbon and hydrogen. So we have carbon. Carbon is a nonmetal. Hydrogen, though it's to the left, hydrogen is also a nonmetal. So since these are both nonmetals, this one is covalent. Next, we're going to talk about oxidation numbers. Oxidation numbers are when atoms give away or take electrons. The atom is no longer neutral. It is written as a superscript. Superscript means up top. For oxidation numbers, the plus or minus indicates gaining or losing electrons. The plus means electrons will be lost. The minus means electrons will be gained. The number indicates how many electrons are gained or lost. Oxygen has an oxidation number of -2. So it is written like this, where you have the symbol, the O, and then the -2 is a superscript. The negative shows that the oxygen has gained electrons. The 2 tells us it gained 2 electrons. Metals versus nonmetals. Metals will lose electrons to become the positive ion, and that is a cation. Cations are positive ions. One way to remember that is cats have paws. They end up losing all their valence electrons. Nonmetals gain electrons, and they're the negative ion. and that is your anion. And that is so nonmetals gain electrons, negative ions, that's your anion. They gain enough electrons to have 8 valence electrons. So looking at the periodic table, we're going to do 2 examples on trying to figure out how many electrons do these need to gain or lose to be stable. The first thing you should probably do, and if you don't do this now with your periodic table, if you forgot it, we will do this in class. You should add your oxidation numbers on top of the periodic table. So you've got +1 on the first column. So the first column is +1, the second column is +2, the third column is +3, the fourth column is +4, -3, -2, -1, and 0. So make sure that you add in those oxidation numbers. So now what you want to do is figure out how many they need to gain or lose. So first you should find gallium. So gallium is right here. If you were to write gallium with its oxidation number is up top, so it would be gallium +3. Because it's a +3, looking at this, it is positive, so that means it's positive, so that means it's going to lose all of their valence electrons. So gallium will lose electrons, and gallium was here, it lost 3 valence electrons. Now let's do bromine. Bromine is right here. So bromine, if you do the oxidation number, is -1. And since it's a negative, that means it's gaining. And because it's 1, it's gaining 1 electron. Because it has 7 valence electrons, it needs to gain 1 to get to 8.